So again, good morning, everyone. I am so glad that you could join us today for our workshop on Introduction to Python for Data Analysis. And our theme for today's workshop is Unlock the Power for Python for Data-Driven Insights. And this is actually a two-part workshop series. And today we are kicking off with part one, Introduction to Python for Data Analysis. So this is for absolute beginners, even if you have zero knowledge of Python or if you are just starting out, you are in the right place. And our next part two workshop will be on next Friday, which is on March 6th. So that will be offer more on data analysis and visualization with Python in more depth. And my name is Sumit Shah, and I will be your instructor for the workshop today. And I work as a data analysis and visualization assistant here at University Libraries Data Space. And our team is here to help you, whether it's guidance, consultations, or just walk-in, or just answering any questions. So feel free to reach out anytime. And I am really excited to have you all here. And we have got a lot of things to cover today. And I promise it's going to be practical and fun. So let's dive in and get started. So let's take a quick look at what's coming up today. So first, obviously, we will talk about Python and why to use Python and why Python is such a big deal. Its motivation, what makes it powerful, and what are its key benefits and its industry relevance. And then we will dive into what can we actually do with Python with real world examples and key objectives about what you will actually learn in the workshop today. And you will also get familiar with the tools and frameworks you need to code in Python, and some essential libraries. And then we will finally start the fun part, hands-on coding session, where you can put everything into practice. And finally, we will wrap up with a Q&A session so that you can ask any questions that's on your mind. So let's talk about why Python is such a popular choice for data analysis. And first up, it's number one language in the field of data science, AI, business, globally. And in fact, over 70% data professionals use Python, and that's a use percentage. So what makes it so powerful? And talking about its key strengths, it's a very user-friendly. It has simple syntax, and it is also very easy to learn, even if you are just starting. And plus, it's open source. By open source means it's free to use, it's free to download, install in your computer, and write code. And it also has rich ecosystems of libraries and packages. Libraries and packages are like ready-made code that you can use to further. You could just use those code. You don't have to write everything on your own. For example, pandas is amazing for data analysis and matplotlib for creating visualizations. So in short, Python gives you flexibility, power, and like a community support, and all things you need to work effectively with data. So what can we actually do with Python when it comes to working with data? A lot. So you can start with simple data cleaning and preprocessing, getting your raw data ready for analysis, and then you can dive into data analytics to cover more insights and trends. And it also makes data visualization much easier so that you can turn your numeric data into some clear, meaningful charts. And exploratory data analysis, which helps understand patterns and relationships in your data. And if you want to go further, Python opens door to machine learning, AI, and even heavy automation tasks. And possibilities go way beyond what we will cover in this workshop series. It can power entire AI system, and so much more. But for this workshop, we will just focus on the essentials to get you started. And here are some example screenshots of what we can produce using Python: heat maps, bar charts, and summary tables. And these are the visuals that make it easy to spot patterns or summarize statistics in your data very quickly. And more examples can be found from our previous datathon winners posters, which are pasted over the walls in our data space. And don't worry now if you don't know what all that means. Later in the hands-on session, we'll create similar tables and charts together so that you can see how simple it is. Talking about what we will actually, the key objectives, what we will actually learn in the workshop today. First, we will cover the very basics of Python, things like variables and data types, and simple looping, importing libraries, and data loading. And then next, we will move into basic data manipulation with Python, like cleaning or filtering. And then we will dive into the basics of exploratory data analysis. And if we have some time left, we might introduce like data visualization libraries, but that's more for the part two. But today we'll just get a solid start. So before we dive into coding, let's talk about the tools we will need. First off, Python itself, it's a programming language. And if you're starting from scratch, so first you need to, for this workshop, we will not be like installing Python or any libraries. We'll be using a different tool. And I will come into that in later. So if you're curious how you can like install Python or anything, any libraries, I just wanted to guide you all to this website of Python where you can download any versions of Python you want. So you can just scroll down, click on download, and just follow the steps. So all our lab computers have Python. We have Python already installed. So whenever you want to just work on Python, or actually locally, you can just use our lab space to do that. And it's free and it works. It has all versions for every like Mac. If you just scroll down, it has Windows, it has Mac, and this is usually recommended for 64 flows or so. So Python, just installing Python is not enough because it's just a language. You will also need to install libraries, especially when you are working with data. You have libraries like pandas, numpy, matplotlib, and you need to install them manually. And again, we will not be installing any libraries. You can follow these tutorials to get an idea on how to install those packages and libraries. For Mac or Windows, it can be found here. So most of you might get confused when you're just starting on any programming language what libraries are. So actually, you can think of them as a ready-made tools. They are like packages, and they make coding a lot easier because most of the codes are already written by some previous programmers, and they are like stored or packaged in some libraries, and you can just import those libraries and just use the functions or methods to do like the data analysis or visualization. And it's very easy to install once you visit the website and just follow the guidelines. Development environments. So installing everything can feel overwhelming, especially if you are just new. You have to install Python, you have to install different libraries, and like you have to set up a lot of things. But that's where development environments come. They make life easier. They come with everything like ready. So you just have to just go to the website. There are two tools. Google Colab, it's free cloud-based notebook for coding and collaboration. And that just require internet and logging with a Google account. And you don't have to like install everything on your own. And you can just start coding. And for this workshop also, we will use Google Colab. And Anaconda is another development environment tool. It's a local tool. It's also free. You can locally install into your computer. especially when you are working on some sensitive data that you don't want to upload in the internet or cloud, then it's a tool to use, run in your computer. And for this workshop, we will use Google Colab, and obviously it's free. It's work in your browser, and you just have to sign in using your Google account, and there's no installation needed. And everything is ready to go. Python and all popular libraries, not just Python. You could also program in other languages in Google Colab. And it's easy to share. It's also easy to share your work together. And also if you need like a extra power for a big task, it even gives you like a free GPU or TPU access. Yeah. And Google Colab also has like a AI assistant built in it. It can give you code recommendations and help troubleshoot as you work. And you will see this in action when we start our like hands-on session. So in short, Google Colab makes everything like easy to start with Python, right? So we can officially get started. So before we officially get started, I just want to pause and let audience have some time for questions. Okay, so if there's no questions, then let's open Google Colab. This link might not work. So you can just type Google Colab and click on the Google Colab first tab. And you should see like this window pop up here. So this link might not work.
Drop the link in the chat again. And if the back one is not, yeah. And
yeah. 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 So you should see the windows like this open up, and you will see all other objects. Here, if you're just starting out, you will not see anything. And since I'm already signed in using my Google account, I see this. I don't know if everyone, I just want to make sure everyone is signed in using their Google account. And you can create a new notebook. You will see this window. And this is the name of your project. You can change it. You can call it Intro to Python. You can name it like this. And .ipynb is like this is like a tag that tells you this is a notebook. So every notebook will have this .ipynb at the last. So you can see there is a code cell, and there are more buttons like text cell. You can add text, you can add code, and you can see all your outputs, everything like within the same window. And this is the advantage of using notebooks. So I hope everyone has reached here, and they have already signed in using their Google account. And you can also see like an AI, Gemini, chat here. So as you code, you can just ask to help AI write your code or troubleshoot your problems. Okay. All right, then I think we should finally start the hands-on session. So we will start coding now. So we will start with very basics of Python, like variables and data types. So Data types is like a different kind of data you can find in a real world. Like you can find integers, or you could find a floating point or decimal numbers, and you can also find like a string, or a string means like a sentence or like a word. And you can store every those kind of data into some variables, and variables are like a containers. So let's start with storing single values like A's. So you can store 21, or and that's an integer. And you can write comments in any programming language. Comments are like, they are like notes. In Python, you use hashtags to write comments. So this is like integer data type. And so yeah, you can store integers, and there are also decimal numbers. So you could say like weight, 127.7 in lbs or something, and write comments again, floating values or decimal values. In programming, floating point is more common for decimal values. And similarly, you could store like a string. So a string is nothing but a word or sentence. And you have to use like a quotation mark to indicate that this is a string. So just saying Sumit won't be enough. You have to use like a quotation double or single. Other programming languages have restrictions on whether to use like a single or double, but Python, I don't think Python has any restrictions on using double or. So this is a string. And similarly, there are other data types like Boolean that stores just true or false values. So is a student, I would say, and is a student or not? Sumit is a student or not? Yes, Sumit is a student. And that's you can see like AI is giving me these recommendations. So to write what AI give you, you can just hit tab and it will be all here. So right now I'm not going to introduce the print statement is you use print to like print those values on the output on the console. And remember, one thing I forgot to mention is while you are declaring variables, there are some rules that you have to follow to declare variables. Like if you have just a single like age, weight, or name, you don't have. But if there are like two words, then you cannot have like a space. There has to be underscore. And there are more, you can find like rules for creating variables in Python. You can follow like any tutorial, and it will show you like what are legal variable names and what are illegal variables names. Like these are legals, you cannot have underscores in between or at the front, but you cannot have like a space or bar or a number at front. That was about variables, and yeah, you can just use print statements to print all those values and run this cell. So this is a run button. So yeah, it printed out all the values. And more about, okay, so I'm going to comment everything at once. You can just hit control and slash and it will comment like everything. If you run it, there is no output because comments, whatever is commented, they are ignored by the program. So you won't see any output, right? And so you could print in a different formats, like you print, let's say you want to print like hello, hello, and then Sumit, my name. You print out hello, Sumit. Or you could print is is. By default, it gives you a space, so you don't have to put a space here. Okay, cool. And there is something called f strings, Python. So f strings refer to formatted strings. So the AI is already giving me a recommendation. I'm going to accept it, and I will explain what f strings are. Let's say you don't have this f here. So this everything under the quotation mark is a string, right? So if you run it, it will print out hello and then the name. But if you have like an f in front of the strings, and this name refers to the variable name, and inside the curly braces, if you have, this will fill in the blanks with whatever is the variable. And you can say, hello, my name is blank, and I am is, whatever is the is, years old. Hello, my name is Sumit, and I am 21 years old. This is of string formatting. So this was very simple, and you can print the data types of each of these variables using dtype. Is you can always ask AI how to data by a variable in Python. So they will give you answer. So it added like another code cell, and it gave. So you use type command to see what type of data. I'm gonna cancel it. I'm just gonna use type and is. So it belongs to class integers. So my is an integer. Similarly, if you print out type of name, and similarly type of everything. My name is string, my weight is float, and my is student is. Alright, so now that we have talked about variables, how can you declare and store in different data types? Let's talk about basic arithmetics. So any Python, you can use any of this cell as a calculator. Equals to will give you 4. You can do 2 times 2, usually star times 3. And if you don't use a print statement, it will only print out the last command. you won't print out the previous one. So you have to use like a print every time you have like multiple commands. You want to display it on the out. Yeah, so print 2 plus 2, 2 times 3. And similarly for power, you use double star. So 2 to the power of 3 is 8. And to divide, you use backslash. So 2 divided by 3 is 0.66. And there are actually two kind of division. In any programming language, there is like a, okay, like 3 by 2 is 1.5. But if you do like double slash, it's only 1. Because double slash is a integer division. It only gives you the integer part you get after dividing. So let's look into more arithmetics using actual variables. So I'm going to store some numbers like a equals to 7, b equals 3, and c equals 5.5. And actually, instead of writing a equals b, b equals c, and c, like b equals 3, c equals 5 and 5, there's a like a shortcut way of doing this in Python. So you could use a single line to, you could use just a single line a, b, and c assign value. And you can say sum is a plus b plus c and print sum. Similarly, you could say like a power something and a to the power of 8. This is 7 to the power of 5.5. And so, yeah, similarly, you could use other different operators and perform very basic arithmetics. Use any Python notebook as a calculator. Now let's dive into. So until now, we saw how we can store like single values or a string in any variables, right? So variables are like containers. So you can add like entire list of, but in real world, you can have like a list of values, not just single values or a string. So in Python, you could store like a list of values into a variable. And even if you are like working with data, what we will do is import the data and store those data into some variable. And you use that variable every time to do like data analysis. So I'm going to add a new code cell and I'm going to say lists. So they are called lists in Python. Let's say you want to store a list of your scores in different subjects in an exam. So you could store it like this. Say 88 in one subject, 92 and 76 in another, 95 in one. So this is a list. And you don't know like what subjects scores are these. You just know the scores and you have the like a numerical like the list of scores here. And And you can simply use the print statement to print scores. Oops. It will print out the entire list. And the AI gave me a recommendation to print out the first score. So each element in the list has like a position, and it's called the index. And the first element has index 0, and then second has 1, and then it continues. So I have like 1, 2, 3, 4. 4 elements in the list. And the index will range from 0 to like 3. So the first score, and this is how you access each element. Like you use this braces and like the position. So if I want the first one, I would say 0. Similarly, like print the last one, and the last one using 3, and the second one. So you printed out the last one, and then the second is 1. And there is also there is a special like feature in Python. So there is a negative indexing. Negative indexing is not in other languages like C or C++. So if you say like a -1, this position means like a 1, the first from the last. The -1 will give you last score. And then the -2 will give you like a second last score. This is a cool feature in Python. And you could also print like a range of values, like not just a single values in the list. Like you can say print score, and then let's say you want to print like elements from first, like elements like elements second to last. You will say the first index until the next. Okay. 1, 2, 3. So it printed out from 1 to 3, and 3 is not included. So you have to use like a 4 to include all these elements. So it will print out all the scores that are indexed from 1 to 3. And like the last one is not included. And in list you have like multiple different methods. And lists, you can like add different values in the list. You can append. So you can append values, you can remove values. So lists are mutables. So that's the word. So they are mutable. In programming, mutable refers to if you can change the values. And like I could say scores, if you want to add values in the list, you would use append word. And pop, you use pop to like remove. So append is gonna append, you say append and then the value you want to append. So append is gonna add 100 at the last. And now you see now my new score has 100. So similarly, you can specify where you want to append your value, like using insert. Let's say I want a value 85 to be inserted at position 2. Right? So you'll see like now my 2 has 76 in it, right? 0, 1, 2, 2 has 76. But now in my two position is 85, and everything, the rest of everything will shift on right. Similarly, you can like remove elements, you can append, insert, and you can also like remove elements. Let's say you want to remove 88. So it will remove 88. And now you can see 92, 85. And similarly, you could pop out elements. So popping out means like popping, if you just say pop, it will pop out the last element. And if you specify the index, it will pop out that the element of that index. So pop, now already is gone. And if I say scores, pop, pop. Clears everything. And pop, let's say 1, I want to pop 85. So 85 is popped here, and I'm rolling, and clears everything. So the list you can, there are more and more like methods in lists that you can change and make different like changes into the list. And there are also in lists, there are also functions that you can use to find like, let's say you want to find the maximum or the length of the string or the minimum of the list. You can use functions like min, max, and length. Let's say if I say print min, max, so yeah, already gave it. So you use mean and then the scores. So I'm gonna formulate everything so that my list is not clear. So you can see the minimum of this score is 76, so it printed out 76, the maximum is 95, and the length is 4, 1, 2, 3, 4. And more methods can be, you can just like follow the tutorials anywhere from the internet, like functions in list in Python. Okay, so list in Python. You can explore more about the list, what methods are. And yeah, I just showed a list of numbers, but it could be a list of integers, or you could just mix it with a different values, integer, all kind of, you can have all mix of data types in a list. And accessing list items, changing list items, you can change it using, and then adding, removing, and all. And you can also sort in lists using the method sort. Yeah. So if I say scores sort and then print it. So you see how the process is done. Okay. So you say sort, and it will sort the score in ascending order and print the scores. This was the unsorted one, and this will be sorted. And you could also say scores dot reverse. reward the list. So this was about lists and what methods you can use to change the list. And this was just some list of like scores, and you don't have idea what subject scores are this. So that's where dictionary comes. So you could map your scores to each subjects. So now we will talk about dictionaries. Python. Python. So before talking about dictionaries, I forgot to mention about tuples. So tuples are also like lists. Everything is the same, but they are immutable. So you cannot use these methods for like score, append, or insert, or remove, or popping, because you cannot change the values in tuples. And so this is how you define tuples using small braces. So you define list using capital rectangular braces, and tuples is defined by small braces. So back to the dictionaries. So now I'm gonna copy the same scores, and we use curly braces for dictionaries, and we can map it to subjects like calculus, 88, and this could be history, and this could be some other subjects like English. We have created a dictionary. Now each value has each value is now mapped to its subject, right? So in list, you access elements using indices. So here you access in dictionaries, you have like a key value pair to every values, and you access those values using this keyword, history or English. And similarly, you could use a print statement to print the dictionary. And so AI already gave me recommendation. I'm going to accept it. So let's go step by step. So print scores. So it will just print the entire dictionary. And calculus score, instead of the index 0, I use this keyword calculus, and it will give me 88 because it's a calculus score. And I use the key value, like whatever key value I want to print out. I just use this key value to get the access of these elements. And dictionaries are really important because, and yeah, this is how, and you could also add into these dictionaries, like you could say chemistry, also 99, and I have added a new chemistry 90 in the dictionary. And so this is just for like one exam score, right? Let's say you have each subject can have different scores for exam 1, exam 2, and exam 3. And you could have a dictionaries a key that is mapped not just to a single value, but like a entire list. So I'll say like scores list, and each of these can be mapped to like a list, not just single values. So these will be the scores for like different exams. Similarly, if I say print course list in so now calculus is mapped to a list. So it should print out a list. And you could use another braces to access the elements in the list that's mapped to calculus. 0. And it will print out the first exam score. 1, it will print out the second exam score, and so on. So you can use this kind of double two-dimensional notation to access using key values and then the elements in the list. And this is important even for data analysis. Whenever you are importing data into your Python notebook, it converts into the dictionary. That's why dictionaries are so important in Python. It will be converted into a dictionary. So your data is nothing but like columns and then rows with some values. So each column is like a key value, and then each key value is associated with a list of numbers or like whatever data it is. So dictionaries are important. And now that we talked about dictionaries, lists, let's talk about another very important concept in. So I hope everyone is clear here until now. I want to take a pause and ask audience if they have any questions. All right, so if there are no questions, we can continue with loopings in Python. So in any programming language, you will find looping. So looping is a very important concept in any programming language. Looping is like when you have to do say some things multiple times, you use loops, and also like if you want to like iterate through each of these elements in a list or dictionary, loops are very, very helpful. And programmers and as a data analyst use loops. We will use loops all the time. There are two ways we can use loops. There are like for loops and while loops. And very simple syntax for a for loop is this. For I in range, so range 10, and then you use what's this called, a colon, and then a tab and whatever code you want inside your loop. So I want to print out for I in range 10. So I want to print out the first 10 like integers. So it printed out 0 to 9 because when you say for I in range 10, 10 is not included, it starts from 0 to 9. But if you want to start from 1, you say 1, comma. And if you want to include 10, you will call it until 11. And there, so range accept actually 3 keywords, and by default it has 1, and it's adding 1 every time. But if you call it 2, it will skip. It will print 1, it will, and then print 3. So it will take jumps. And then 5, it will take 2 steps. And it will print 9. So this is a very simple for looping in Python. And let's say you want to print out like these are odd numbers, like you can print all odd numbers less than 100 or something. Or you could start with 0, and this will give you all even numbers less than or equal to 100. And you could start with an empty list, like squares, and then you could like add elements into this list. Call it squares or the let's say I want squares of Boston. So what it's doing this is it's appending squares in this list every time. So so I is first 0, it will append 0 square into the list, and then 1, and then and then it stops. And let's say you want to iterate through a list. You can iterate through the list, each element in the list, like this. Like for scoring scores. So for scoring scores, just like for I in range, so range 11 is like a list of numbers from 0 to 10. So this is also a scores, and scores is a list, and this score refers to like each element in the list. If you print out, it will print out like every element. 100, and it print out 100. And let's say you want to like find a sum of all the scores that you get in all your subjects. You can start a sum variable with 0, and then you could use sum plus equals to sum plus equals to score. So you are adding sum plus equals to score every time in sum. So you are adding, so in the first loop, okay, so now let's print sum. $451. So every time we are in the first loop, my score is 88, so it will add 88 to 0. In the second loop, 92 will be added to 88, and in the second loop, 76, and so on. And then finally, we will come out of the loop, and we will get the sum. Now that we know like how to loop, we could do a lot of things like calculate the average in the list. So what is average? Average is nothing but sum over the length. And we know there is a function called length that will give you the length of the scores, right? And you can print out the average. So, yep. And while loops is also like for loops. You just use the keyword while. So you have to start something with a counter, something like counter is equals to 0, and while counter is, so you put some conditions like while my counter is less than 10 or something, I want to increase my counter. So I'm increasing the counter, and I have a condition while it's less than 10. So it will stop whenever counter value is 10. It will stop from up. And you could explore more about loops, of course, using the same tutorial. This is just to get you started with. And there are also, you can also define functions in Python. Like functions are, what are functions? So the functions are basically a block of code. So you could have like let's say for example, I have this code, right? I want a function that will take score as an input and then it will return me an average. So you could have a function that is, you could define a function like AB average, right? And then if you pass scores list, and then everything we put it inside. Now, my block of code is packaged inside a function called average. And then after I am done with summing, I will return the I'll called average equals to sum over length of scores, and I'll return the average. So this is packaged into some function. Now I can use this average function and plug in like any other score values. It can be anything, not just scores, like scores 2, 120, 140, 150, like whatever. I have a function now. And whatever list I have, I can just plug in into the function and it will give me scores. Like let's say average of this is 90.2 and average of, I want the average of second list scores 2. So let's say you have this function defined somewhere and you don't know the logic how to find the average. You can just reuse the function average every time to calculate the average. And this is how everything in the libraries and packages are. So you have all the functions defined, all the like classes and functions, and you just import those libraries and use those functions to find like any statistics. So this was very basic, again, very basic about Python, functions in Python. You can again follow these tutorials to like dive more into functions. You could pass me as many arguments as possible. This has only, we are passing like scores as a argument in this particular function. Okay, so now that we have talked about functions, so I don't think we have much time left. So I actually had an exercise for the audience. So I don't think I have now time for everyone to do the exercise, but I'm gonna still put it here just in case someone wants to try it. So the exercise was to so the exercise was to like create a study of like statistics of the data, finding sum, average, and then packaging everything into a function that will return the dictionary of the statistics summary. But we will be sharing this notebook to everyone, and they can try doing the exercise on their own. And yeah, you can always reach out if you have any questions. And you can always start like AI to help you getting started with solving the problem. So without any further delay, I want to go to talk about libraries now, how you can import libraries. So you can simply import libraries using keyword like import, right? So let's say you want to find like a square root of some number, but you don't know how to write a logic of square root on your own. Then like, or any other like math functions you want to do, and you don't know the logic, you can simply import like a math. So math is a library, you can import it, and it has all like square root, cosine, and sine functions. So if you say like, I want a square root of math dot, you say math dot sqrt is a function, square root of 49. That's 7, right? And let's say if you don't want to use math dot every time, you can just import math as m. Like now you are importing a library, and library has a name m, so you can just use m every time. In the square root of something, you can store it in a variable like answer. Answer. Let's use another more complicated example like 120 is data from 120 square root. Yeah. And let's say if you want to print just two decimal places, there is a function called round answer comma 2. So it will round your answer up to two decimal places. Yeah. And similarly, there are other like libraries like random, import random as RD or something. And this you can use this library to like generate random number. And like you could say RD dot ramping 1 to 10, and you could store 8 in some variables like numbers, and it will give you numbers. So this will give you the list of random integers between 1 and 10. Like one random, not the list actually. A random integer between 1 and 10. You know, every time you'll see like you get. And there is also another library like NumPy as NP. This is also another popular library. So pandas, there are other matplotlib and other libraries. So this is how you import libraries every time. And since I'm not getting any error here, if you were working locally, then if you do not have these packages installed, then you will get error. Because we are working in a cloud, Google Colab, they have everything installed already, so we are not getting any errors. So now actually talk about the libraries that we need for data analysis, right? So what libraries we need? We need pandas. So let's say you want to bring your data into your working environment, into your working directory, into your notebook. You have to use some kind of libraries. And pandas is a very popular library, and everyone imports pandas as PD. It's a popular choice. And So before working with data, you have to load the data, right? You have to load the data and store it somewhere. And I want to store it in some variable called df. So df simply refers to data frame, and you call like data.csv. If it's a CSV file, you call it data.csv. And to upload the file, actually, you have to upload it here before you import your notebook. So you go to, if you can see this icon here, you can upload your data set. You do this upload. And I hope everyone has downloaded this data set already. If not, I'm gonna attach this data in the chat so that everyone can download it and just import it. You can just, okay. So now you can see my workshop1.csv is here in this folder, and I will replace this data set with the actual workshop1.csv. And you can see like a check button. That means your data is successfully loaded. And if I say like workshop.csv or something, it will throw error because there is no any workshop.csv data here stored, right? So workshop1.csv is here, so we are good to go. And now that we have imported the data successfully into some variable called df, we can actually print the df, like data frame to see. And this is my data, what my data frame looks like. It has columns like age, gender, or something, and then it has 10,000 rows times 10,000 rows, and they have 12 columns, 12 different columns. And there are more functions you can use to explore your data set, like df.head. df.head. It gives you the first 5 entries of the data set, and it's more better way to look at your data. You can see it has like a age column, gender column, and so it looks like it is some kind of insurance premium data set, right? And you can specify, you can give arguments like and it will print out the first 10. And I can see there is some values like NaN here, like NaN. So these are all null values. In data sets, you sometimes have null values. Those are values that like are not filled whenever you take survey. They are like blank spaces, and you have to like clean those data, right? And before you start any data analysis, you have to make sure your data is cleaned properly. You have to replace all these null values, or like you have the ability to get zero nodes. And similarly, I can see the shape using a function shape. It has like 10,000 rows and it's 12 different columns. And you can use columns methods to see what columns are there in the data set. So it has age, gender, and so on. So this was about exploring your data set, looking at the dimensions, looking at what columns you have, and yep. So checking for null values. As I said, we had some null values, but we cannot see all at once, right, in a data set. So we can use some commands like df.isAny.null. if you run this, okay, so you have to use braces. Oh, no, sorry, some. If you run this command, so it will give you all like the counts of null values each column has. So A's has 312 null values or missing values. Similarly, this column has 86, 40, 480, and like different columns have different, and 0, they don't have uh, values at all. So it's better to like, so we have like 10,000 entries of data sets. So that is enough data sets. So you could just drop all the null values, right? And how do you drop null values? You could simply say df dot drop, when you drop any function, and it has dropped all your null values from df. And if you try to use the same command in a new code cell, did you drop it? You can use AI to find like the syntax or commands. Like I asked how can I drop null values? Drop any. Okay, we have to drop any. Here. Really. Now, now, since everything is dropped, I have no any null values in any columns. And if you again look at the save, df.save, and now it has 8,000 something entries because we had some missing values and it dropped those all. And similarly, you could find like do more and more things. Like you could check for duplicate values, and you could find like other ways to replace null values instead of dropping. In case you don't have like enough data set, we have to find a way to replace those null values with strong values. And that's called data imputation, and we will go more into like depth into all that in our second workshop. I think this is gonna be the end of this workshop. And again, like there is much more to explore about Python. Like I went through a very basics of it, and just to get you started, just to get you comfortable with Python and how you can declare variables. You can import data and start working with data and exploring your data sets. And our next workshop will be more in depth on data analysis. We will directly start by importing a data and then go into exploratory data analysis and visualization libraries. And I think we have 7 more minutes. I want to leave the rest of the time for our audience to ask questions. And we will be sharing this notebook in case someone missed any. And if you're working in a notebook and you don't know like where your notebook is located, in case you lost it, you can go to File and you can go to Locate in Drive. And it will give you the location in Drive. And don't forget to try this exercise. All right, thank you everyone for joining the workshop. I hope you enjoyed the session. We have 5 more minutes for questions. And please don't forget to join the part 2 of this workshop next Friday. We have more fun things to cover.